In this video, you will learn about heat capacity and specific heat capacity. What is heat capacity? The heat capacity of a body of matter is the quantity of heat it absorbs or releases when it experiences a temperature change of 1 degree Celsius. Okay, so let's just, by definition, we are going to see some examples later on. And heat capacity is an extensive property. What does that mean? If you look at, if I have two objects, let's say I have a pot of water or glass of big glass of water and a small glass of water. Okay, and let's say I want to increase the temperature from let's say by 1 degree, so I want to do it from 50 to 51 degree over here also 50 to 51 degree. Which one will absorb more heat in order to raise 1 degree? Okay, of course the big part. And by definition, heat capacity is per change in degrees Celsius. That's the heat that is needed. So over here, the heat needed will be bigger. So in this case, the bigger object will have a higher heat capacity. Well, you'll see more of these examples later. Okay, so let's talk about specific heat capacity. So what is the difference? If you look at the one before, what you see that is that with a capital C, heat capacity is equal to heat divided by delta T. What happened here? The small c, that's a specific heat capacity. You have an additional m over here. This is the mass. So that means specific heat capacity is the heat absorbed in order to increase per gram by 1 degree. In this case, because it's divided by the m already, and therefore this quantity over here, it is an intensive property. Okay, so let's spend some time and try to memorize this formula, especially the specific heat capacity. I can rearrange the equation, and what you can see is I'm going to isolate the Q, the heat over here. So heat is equal to C times M times delta T. If I rearrange this formula, I will have Q equal to M times C times delta T. Okay, I purposely write this delta look like an A, so it will be easier for us to memorize it. That means heat is equal to MCAT. So MCAT is a type of test that students want to go to a medical school. Okay, so that would be easier to memorize. Remember, this is a delta, it's not an A. Okay, so heat is MCAT. Well, that is only my way of memorizing it. Okay, let's go ahead and see if we can use that to solve any problems. Let's look at the first one that I have prepared here. A 22.9 gram sample of iron absorbs 155 joules of heat, okay, upon which the temperature of the sample increases from 23.9 degrees Celsius to 38.9 degrees Celsius. Well, we need to go over the unit very soon. Okay, so let's see what we have. Let's talk about units first. When I talk about heat capacity, before what we see was amount of heat for that object to change by 1 degree Celsius. Okay, so heat is either joules or calorie. In this case, let me put it joules first. Joule per degree Celsius, that would be the unit. How about small c, specific heat capacity? It will be equal to Q divided by M times delta T. Over here, Q, that's the heat, either be calorie or joule, divided by mass we can say gram, kilogram, but we have to be in the unit of mass, and then degree Celsius. 1 degree Celsius is the same as 1 degree Kelvin if you look at the difference. Okay, so let's say if something is 273 Kelvin, and that if we go up to 274 Kelvin, exam is from 0 degree Celsius and go to 1 degree Celsius. So the difference over here will be 1 degree Kelvin, and over here will be 1 degree Celsius. They are the same. 1 degree Kelvin in difference is the same as just in difference, the same as 1 degree Celsius. Okay, let's look back to this. What is the specific heat? Okay, so specific heat, small c, is equal to the heat divided by m times delta T. Okay, so that will be 155 joule divided by m, that is the mass, is 22.9 times delta C. What is delta C? Delta T, excuse me. Delta T is final temperature. Delta T is final temperature minus initial temperature. Okay, so over here, final temperature is 38.9 and minus initial temperature is 23.9. All right, so if you put that into your calculator, we should get some type of answer. So 155 divided by 22.9 times 38.9 minus 23.9. What I get is 0.451. So I get 0.451. What would be this unit? It will be joule per gram per degree Celsius, or joule per gram per K. Okay, so in this case, yes, I find an answer over here. All right, let's look at the next example. Well, in this diagram, in this picture, we try to show the difference between heat capacity and specific heat capacity. So the heat capacity will be different for the two parts, because the bigger part will require more heat to raise one temperature. But as for the specific heat, because it's per mass divided by gram, so for the specific heat, they will be the same. Okay, specific heat for these two objects would be the same. So in general, it's about what material it is. So we generalize it, no matter what shape it is, as long as it's the same material, that means they will have the same specific heat capacity. Okay, so here's the chart. And by the way, you do not need to memorize this. If you do need to memorize one of them, you can memorize the one for water. Okay, so water, the specific heat capacity is 4.184 joules per gram degree Celsius. And it is the same as 1 calorie per gram degree Celsius. Okay, let's look at another example over here. Over here, a flask containing 800 grams of water is heated, and the temperature of water increases from 21 degrees Celsius to 85 degrees Celsius. Okay, how much heat is needed? So when we look for the heat, my favorite way of saying it is heat will be equal to mc delta T. Okay, so now let's look at it. If we look for the heat, I just have to plug in what is m. M is the mass, which is 800. What is the C? Okay, so the C over here is specific heat capacity of water, and that is 4.184 joules per gram degree Celsius. What is my delta T? Delta T is T final minus T initial. In this case, it will be 85 degrees Celsius minus 21 degrees Celsius. If we plug everything in together, what we will get is 2.1 times 10 to the 5th power joule. And if you want to convert that into calorie, you just have to divide that by 4.18. So let's do this as an example. How about let's put everything into calorie? I don't like the unit of joules. Okay, so let's start from the beginning. Of course, you can just divide this number by 4.18. So let's say I want to do from the beginning. All right. Let me put in another color. Okay. So the formula would be the same. I'm looking for heat. When I look for heat, I'm happy because I can memorize the formula. MCAT delta T. Okay, so that would be equal to the mass would be 800 g gram. What is the specific heat capacity for water? It is 1 calorie per gram degree Celsius. Okay, and then what I need to do is I also need to get delta T, which is 85 minus 21, that many degrees Celsius. Okay, so what you need to do is, so you have 800 multiplied by 85 minus 21. I got, in terms of calorie, small c, 51200. In other words, is that many calorie. Okay, if you want to write in the capital C, it would be 551.2 big calorie. Okay.